Right, so welcome to lesson 1 of organic chemistry. So as you'll see, you've got your front page booklet. We're going to go through lesson 1 today on how is crude oil made and what is an alkane. So if you turn to page 4, you'll see our first lesson is on alkanes. We've got a bit of specification information. What I'd like to do to begin with is I'd like to start by having a look at the knowledge check on page 4 and page 5, seeing what you, what you can do from past memory, and then we'll go through the answers in a moment. So if you'd like to pause the video, have a go at these questions, and then we'll go through the answers in a moment. Right, hopefully you've unpaused the video. So if we go through the answers nice and quickly, fossil fuels, 3 of them: coal, natural gas, and oil, crude oil. Type of bonding between non-metals, that is covalent bonding. Name the energy between atoms in a molecule. They are bonds. The forces between molecules is intermolecular forces. And then if you turn over, you'll see you've got the next 4 questions. So an endothermic reaction takes in energy from surroundings. Units of temperature is degrees Celsius. How do atoms and molecules move when heated? They move faster or quicker. Name the energy stored of moving atoms or molecules. They are kinetic. So, let's have a look at organic chemistry and what it's all about. So if we go through this text to begin with, organic chemistry is associated with the molecules derived from living organisms. So if you remember, when we're talking about things that are living, you might remember us talking in early years about Mrs. Gren. It stands for movement, respiration, sensitivity, growth, reproduction, excretion, and nutrition. So organic molecules are carbon-based and tend to be the center of molecular life. So you've got examples of organic molecules include things like lipids, proteins, DNA, carbohydrates. These are molecules all within living things. Carbon in group 4 of the periodic table. So remember, if it's in group 4 of the periodic table, it has 4 electrons in its outer shell per atom. It's very versatile, so it's good at doing different things. As it can form 4 covalent bonds. So that number is important. And also, when we're talking about atoms forming covalent bonds with each other, that means they share electrons to get a full outer shell. Okay, that's the next bit of the paragraph. Crude oil is a finite, limited resource in rocks. So remember, if it's finite, if it's used, it will eventually run out. Crude oil is the remains of an ancient biomass consisting mainly of microscopic plants in water called plankton that were buried in mud. So when we're talking about biomass, what that means is it's the mass, or the collective mass, of organisms in a specific ecosystem. So what we're talking about is we're talking about the mass of all of this plankton that's living underwater, that if you were to combine it. Now the plankton was then died and were buried in mud. They didn't decompose in the usual way. So remember, decompose is another word for break down. In the usual way, because they're exposed to high pressure and heat for a long time, causing their carbon-based molecules to form oil. So what that was causing those organisms to do was to chemically change. So the amount of pressure determined if the crude oil also became a natural gas or became oil. So this chemical change is determined by the amount of pressure. Crude oil is a mixture. So that is different substances that are not chemically bonded. A very large number of compounds. Most of the compounds in crude oil are hydrocarbons. So they're made of hydrogen and carbon. And because they're a compound, that means the carbon and hydrogen are chemically bonded. Most of the hydrocarbons in crude oil are hydrocarbons called alkanes. So alkanes are made of hydrogen and carbon, chemically bonded together in different amounts. Then, the general formula for the homologous series of alkanes is CnH2n. So what this is telling you is you can work out the number of hydrogen and carbon atoms in a molecule of an alkane. So this allows you to work out the number of atoms in an alkane molecule. So the simple rule is if you're given the number of carbons, so for example Cn, you double the number of carbons and add 2. And what that does is it gives you the number of hydrogens. So that's the rule. Double the number of carbons and add 2 to get you the number of hydrogens. And you've got examples of alkanes that have different names. They all end in ANE. They all end in ANE. And because they're an alkane, we describe them as being saturated, which means all their bonds are being used. All their covalent bonds are being used. Good. So, if we turn on to the next page, we can show you some examples of these carbon atoms. So, ethane, you've got 2 carbon and you've got 6 hydrogen. So, we've got 4 others. Methane, propane, and butane. Okay, so we have 1 carbon, we have 3 carbon, and we have 4 carbon in these. So if we've got 1 carbon, we double it and add 2. 1 doubled is 2, add 2 gives us 4. C3, 3 doubled is 6, add 2 gives us H8. 2 doubled, add 2 is 6. So 2 doubled is 4, add 2 is 6. 4 doubled, add 2. So 4 doubled is 8, add 2 gives us 10. And so each of these little lines represents a single covalent bond. And remember, all the bonds of the carbon atoms are used up. So you have 4 bonds per carbon atom. They're being used up. Remember, 4 bonds per carbon atom. So where we've got 3, 1, 2, 3. So we've got 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, all being used up. Same idea applies. H, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's how you draw them. If you want to, pause the video and see if you can have a go at drawing hexane, where you have C6. So what would be the H? what would be the H and how would you draw it? If you want to, pause the video and have a go at that, but otherwise we will carry on with the next bit of the section. So, combustion of hydrocarbons. So hydrocarbons are incredibly useful because they are a really good fuel. So they're a really good fuel to use for energy. And if you remember, when you are combusting something, you are burning it in oxygen. Burning in oxygen. So, burning hydrocarbons in oxygen is called combustion, which is an example of an oxidation reaction. So, an oxidation reaction can be where you add oxygen to a compound. As the hydrogen atoms have gained an oxygen, so that's why it's an oxidation reaction. An oxygen atom to form water. So if you remember, the chemical symbol for water is H2O. And the carbons have gained oxygen to form carbon dioxide. So compound is formed, chemical symbol CO2. During combustion, energy is given out from the chemical bonds into the surroundings, making it exothermic. And the key thing is that this energy can be used. Energy is used. So that is why you burn fuel, to release energy. The reaction yields, so remember yields, gives out, creates more energy when the bonds are reformed compared to when they're broken at the start, which must be passed into the surroundings. So remember, this energy is given out, making the reaction exothermic. The usefulness of this property is important. Another word for paramount is important when using these as fuels. And if you remember, the opposite of exothermic is endothermic, where you take in energy. Good. So if you just turn over and you'll see the equations for combustion. Now remember, there are two types. So complete combustion is when you are burning insufficient oxygen. Burning in enough oxygen. Incomplete is when you're burning, as you'll see, in less oxygen. Which means the products are slightly different. You still produce water in both of them, but in incomplete combustion you produce carbon monoxide instead of carbon dioxide because there is less oxygen in the reaction. Now, carbon monoxide is a poisonous gas that binds to the hemoglobin molecules in your red blood cells. Now, hemoglobin molecules, important, they're made from iron, and basically, carbon monoxide binds strongly to the hemoglobin. And because it binds strongly to the hemoglobin's job is to carry oxygen. But if the carbon monoxide binds in its place, less oxygen is carried, and that causes respiratory problems. That causes respiratory problems. Now, the flame produced during incomplete combustion is yellow, whereas the flame produced during complete combustion is blue. So that is how you tell the difference. So that's how you tell the difference. Good. So a brief, quick recap of the first lesson of organic chemistry. To finish, rewatch the video and see if you can have a go at these knowledge check questions. When you've done that, we'll go through that and then we'll call it a day. Good. So if you've paused the video and had a go at the questions, you can now unpause it and you'll see the answers as we go through them. So the number of bonds in a carbon atom, 4. They are covalent. Where do you find crude oil? Underground. What's the two elements that make up hydrocarbons? Hydrogen and carbon. Names the first four alkanes we went through: methane, ethane, propane, and butane. Write the general formula for an alkane. So this is what you use to work out the number of hydrogen atoms in a alkane molecule. Cn, number of carbon atoms, HN2N plus 2. So N, you double and add 2 to get the number of hydrogen atoms. So why are alkanes saturated? Because all the bonds are being used. Describe the relationship between boiling point and melting point in molecular size. Boiling point and melting point increase as the size of an alkane increases. Now, why is it important for boilers in people's homes to receive regular service and check-up to ensure the inlets? It's to avoid carbon monoxide being produced, which, as we've discussed, is poisonous. I think there might be a couple of questions on the other side. So how is crude oil formed? By increases in heat and pressure being applied to dead remains. And why is crude oil such a valuable resource? Because of the energy it makes. Good. That's the end of lesson 1 of organic chemistry.